Let the birds sing. And when we image the birds' brains, we can see where the brain areas are activated.
Sebastian. Han skal også snart i seng og sove. Fordi det er jo dansk tid.
So what you see here is an image of a part of the brain of a songbird. So the animal's beak is here, and this is the back of the head here. And these are the areas that light up when a bird sings its learned vocalizations. These are similar to brain regions that we have for speech. How in the world did all these species get a similar circuit? We didn't have an answer.
No.
8 years later, an accidental discovery. I was helping a colleague try to identify brain areas involved in bird migration. And one of the things we had to do was to get the birds to just flap their wings and make movement behavior as if they're going to fly and migrate. Because we wanted to see the brain areas that were activated when they move. And when we imaged the brains, we saw a surprising result. Activation around the song-learning brain regions.
Hørte du, hvad der blev sagt, Ine? Der blev sagt, uden at hoppe nu.
The brain regions that were active in the hopping and in the movement of the wings were directly next to the vocal learning area. That told us that there must be some relationship between the movement areas and the brain areas that control spoken language. So that led us to motor theory of vocal learning origin. We argue that the brain pathways that control speech evolved by duplication of the brain pathways that control gesturing in the hands and other body parts. What it means is that the vocal learning circuit of these birds, the speech circuit of humans, is a motor circuit. A set of neurons in the brain that then control muscles. And that's what's controlling your speech.
Just put this one in here, look. Will I push it?
So think of spoken language as learning how to coordinate your body. It's using a similar kind of circuit.
What is it? It's bubbles.
Sebastian.
Bubbles. Bubbles. Oh, look at all those bubbles. Bubble.
This is why understanding language occurs in children before the ability to speak.
Oh, did that one go on your nose? Did it go pop?
Just like learning how to walk, speech comes with a delay.
Pop.
You gotta practice.
Willow.
Practice makes perfect.
Pop. Bubbles.
And it's okay if it's hard to do. Because it is a hard thing and it came later in our evolution.
Can you say bubble? Bubble. Good girl. Pop. Bubble.
Help your child practice speech.
You see the bubbles?
You just got to do it over and over again, so it takes time.
What number is that? 3, Nelson. Well done.
What's this?
Pussy. What's that? Monkey. What noise does it make? When they start speaking, you're not expecting it. What color is this one? Yellow. One day I was doing something and all of a sudden he was 1, 2, 3, 4, 5, 6. And what's this one? And then some random words. Chicken. First of all, he started with one-word sentences, and now he's moved on to 2 word sentences and 3 word sentences. I'm just amazed. Red means stop. That's right.
We humans are along a spectrum with other animals when it comes to spoken language abilities.
Lion!
But we are at the far end of the spectrum, allowing us to have more complex language. And so I've always asked the question to myself, what makes us so much further at the far end of this spectrum? What is different with our brains or with our genes? In 2012, an intriguing discovery was made that humans have an extra copy of one gene that functions in the brain. This gene is called SRGAP2. This extra copy of this gene in human babies maintains extra connections in the entire human brain as they become adults. Humans have more cells now communicating and talking with each other, enabling greater sharing of information amongst cells, but also better learning.
Catch it, catch it.
Bubbles.
Så får vi ham lige igen. En lille bandit er ham Sebastian.
So when I heard about this discovery of this extra gene, I put that together with our understanding of the language pathways and proposed that maybe this is what allows humans to be more advanced on that spectrum for language abilities compared to other animals.
Hi, baby. Honey, Sebastian.
This would allow us to continue to add more sounds to our language repertoire over our lifetime.
Whoa, there's lots here.
Look up.
And thereby allowing us to have greater ability to produce things like poetry, fiction, express our ideas, make movies, make shows and plays, and make us human.
Ready, set, go.
Learning has really accelerated recently, and he's very forthright in telling us what
Hi,
he
baby.
wants.
No, baby.
Is that funny?
Honey,
Door, that's right.
Sebastian.
Open the door. No, you don't want to go outside yet. We'll go outside.
Too cold, too cold. His actual words has increased hugely, so he's able to communicate a lot better with us. He's also very good at saying no.
Hi, baby.
Doesn't say much yes.
Det her, det er
Sometimes he says
bandit.
no with a bit of sass.
Det er lille
Can you do that?
Sebastian.
No, no, no. No, no.
There's a confidence as well. Say he can be part of the conversation. That means he just talks loads more. What's this? What's this? Shoes. That's right. It is the wonder of a baby.
Shoes, that's right. Hey, little one. For a story. Time for sleep time. A Busy Day for Birds by Lucy Cousins. Can you imagine just for one day you're a busy bird? Yes, a bird. Hooray! The sun is going down and everyone is sleepy.
With language, we can recombine many different sounds into many new meanings.
Tous me mettre sur ma branche, dit Sarah. Et c'est ce qu'ils firent, tous les trois, ensemble, sur la même branche. Dans le trou,
Recombine syllables into words, words into whole sentences, sentences into paragraphs, paragraphs into chapters, chapters into whole books.
Oh, look. Open the red coat. Open. And this one?
I think stories are very magical. They're moments where we really connect with our children.
Say, hello, darling. Then swoop like a starling. Yeah, turn the page.
We can delve into a story and land in a world that we've never seen, that may not even exist. having words take me to this place, that is a gift that human language gives us.
Không nào nào nên tôi cũng đi đi nào. Tôi sẽ hoạt động.
She's had a week of just awful sleep. She was waking up probably about 10 plus times a night.
Are you being naughty? To sleep at all?
Getting your baby to sleep through the night turns out to be a universal human challenge.
You really need to sleep.
Vad lille Sebastian.
A baby sleeping is not just important for its parent's sanity, it's fundamental for the baby's development.
A newborn baby is spending 16 hours a day sleeping. That's an extraordinary amount of time to be asleep. There's a lot of mystery there about what's going on in these babies. Why are they sleeping so much?
What an exciting day you've had. You've seen everything.
It's odd as well.
The brain is absolutely on fire. It is very, very active during sleep. This is, in some sense, me time for your brain. This is the time when your brain lives out its own existence, if you will, but you're unaware of it, which is, for me, absolutely fascinating.
I feel like we are really just at the tip of the iceberg with sleep science. We feel better during the day, we think better during the day because of something that's happened in the brain during sleep. I want to understand, how does sleep make you better?
We kept saying to everyone, oh, he's sleeping 5 or 6 hours at night, it's great.
Time for an change.
The last couple of days that stopped. So it's been back to every sort of 2.5, 3 hours waking up for a feed again. Putting him down, you've got that initial, oh God, please keep your eyes shut.
Yeah, we're on clockwork, pretty much 2 a.m. It's awake. So, going and grabbing nappy change, get his bottle ready and then give him a feed.
Sleep deprivation is really hard. No one's used to waking up every 2 or 3 hours and having to deal with a crying baby. It really affects you